All right, students. So this question is from the topic of projectile, a very interesting question. Before you start reading the question, don't forget to subscribe to this channel. Please also don't forget to join my community. You will see some excellent questions coming your way, which will give you a lot of conceptual clarity and understanding of the physics. Your stress level will go down. You will be able to solve the problems and get high marks in the examination. Let's read the question. So the situation is you have a situation where a projectile is fired, right? And it is fired with 10 meter per second at an angle of 53 degrees. Okay. Now, the moment you fire the projectile, you also have a wedge. Okay, the wedge is 53 degree and the wedge also starts moving with 1 meter per second horizontally. What is known to you is the distance between the corner of the wedge and the projectile origin is given to be 1 meter. Now this question, a lot of students will attempt in a certain manner. If there's a way you will attempt this question, where, and I'll tell you where is the mistake in that thought process. So I will show you a way to solve this question, which instantaneously comes to your mind, but then you miss a point there, right? I hope you have read the question now. Let's start solving it, okay? All right. So the idea is to explain you how to attempt this question, okay? See, when I looked at this question, the very thought in my mind was, okay, so let the time at which they meet, which is the projectile and the wedge meets, be t. So the distance traveled by the projectile in time t will be given by the ux component, which will be the 10, the cos of 53 multiplied by t, which is equal to 10 multiplied by 3 by 5 into t. For your information, always be sure that sine 53 and cos 53 are known to you and memorized. Okay, so this becomes equal to 6t. Okay, now you will say the velocity of the wedge is 1 meter per second in t seconds when they meet, right? And keeping the origin as this, the wedge will move a distance of, so I'm writing wedge here. Okay, so this is the wedge. 1 plus 1t. And now the tendency of the student is to relate these, right? So 6t is equal to 1 plus 1t. Get a value of t. Once you get the value of t, what you do is you find the height of the projectile, convert this into y, and you will get a figure of 7 by 4 meter per second, right? Something like that. So, but there is a fundamental error in this thought process, which actually, when I saw the question, immediately created an alert in my mind. And the alert is, why did they give this 53 degrees for the wedge? If this is the approach we need to take, that this is the distance of the projectile and this is the distance of the wedge, then why was this information available to us? Why this 50 degree has been given? There is a reason. See, the height of the wedge is located here. Okay. So if I were to say my reference point on the wedge which moves is not this point, but this point. Okay. Now if I look into this, if this is a fixed length of x, okay, this is a fixed length of x, then the projectile not only has to move 1 plus 1t, right, which is actually meant for this point, the first point, but it has to move an additional x, because now the distance between the point of projectile and the point where the height is located is 1, and the balance of the distance is x, right? So you can see that the total distance it will move in time t is just not 1t plus 1, but another x, which is the base of the wedge. It has to move that. The base of the wedge also needs to be accounted for in this. It's a fixed quantity, no doubt about it, right? Now, so we know, so the equation looks like this. Now, this is a two variable situation. I think the base of the wedge is unknown, right? But this is the point we are worried about, the height. Now, how do you calculate the height of the projectile? The height of the projectile is calculated by y is equal to uyt plus half gt square is equal to uy, which is 10 sine 53, okay, multiply by t, which is the same t as you would get from here. Uh, and the gravity is always acting downward. So minus half into 10 into t square is equal to 10 multiplied by 4 by 5 minus 5t square. Okay. This is, this is t, and this becomes 8t minus 5t square y. So, for example, this is where they meet, right? This height has moved by a certain distance in the time, which is the total distance moved is as measured from the origin is this much, right? So we know the overall point of meeting, and the height you have attained as a projectile is this much, right? So at this instant, if I say your wedge is located here, you are at y height, you're at y height, and you're located here, right? So this is your x coordinate. The overall x coordinate is this, out of which this particular one is the wedge base, right? So you have reached this point. This is your y coordinate where you have reached, and there is another thing happening, which is your base. The base also has moved by a distance. From our point of view, we were always worried about the point which is this, because it represents the height. That's our x coordinate. So we have two equations now, right? We know y is written like this and x is written like this. What do we do now? Remember, y by x in this situation, the maximum height at which the projectile is just able to, is crossing, and we have to say what is the maximum height of the wedge you can keep. We should know what is the y for the projectile. If we know the y for the projectile, we will decide that the wedge has to be slightly smaller than that, or at least equal to that, right? So what I do is I rewrite this equation as say 5t, okay, minus 1 is equal to x. And I know this, right? So this becomes my equation number 2. I took the t on the other side. This became 5t minus 1. So I know x is equal to 5t minus 1 is my equation number 2. What I do now is I divide the two equations and I say y by x is given by 8t minus 5t square upon 5t minus 1, right? So I know y by x. If I calculate tan of 53 degrees, it will be equal to 4 by 5. So this is coming out to be 4 by 3, right? So this is 4 by 3. This is 4 by 3 is equal to 8t minus 5t square divided by, so this is half gt square, right? So this is safe, 5t minus 1. Let's do a cross multiplication, and what we get is 20t minus 4 is equal to 24t minus 15t square, right? 24t and 20t should have become 15t square goes on that side. This should have become minus 4t, right? Minus 4. This should have been the correct. So I will just resolve this. All right. So just have a look at the quadratic equation we have got. I think the part was hidden, so I added this back. So this is 20t minus 4 is equal to 24t minus 15t square. bring everything on the left hand side and you will be able to get this 15t square minus 4t minus 4. And this is the quadratic which I am solving. So I think a quadratic equation so that we can. Okay, so I will just resolve it. So my t will come out to be minus 15 plus minus. This is 15 square. Sorry, 16. Sorry, this is b square. So this is 16 minus 4 into 15 into 4 divided by 30 is equal to minus 15 plus minus under root of 16 plus 60 and 4, right? So 64s are 240 divided by 30, right? So this will become minus 15 uh, plus under root of 256 divided by 30 is equal to minus 15 plus 16 divided by 30. So the correct choice you get from this is minus b, right? Uh, Minus b. Why have I written this? This should be minus b, right? So this is my 4. Okay, this is my 4 plus minus. So 4 plus minus 4 plus minus 16, right? So I will write it as 4 plus 16 divided by 30 is equal to 20 by 30 is equal to 2 by 3. So the time at which they meet is 2 by 3 seconds, right? So for this time, what is the value of y? Let's calculate the value of y here, right? So the y becomes equal to 8 into 2 by 3 minus 5 into 2 by 3 whole square is equal to 16 by 3 minus 40 by 9 is equal to 9. And this becomes 3 3s are 48. And this becomes 48 minus 3 3s are 40. This is 5 4s are 20. Sorry, this is 20. And this becomes 20, right? So this becomes 28 by 9 meters. This is the correct answer. So a lot of calculation error, no doubt, but finally we have got it right. So the answer is 28 by 9 meters. So you could see, I think the missing point was what was the reason why 53 degree was given. If you recognize this 53 degree, that's a key. If you fail to recognize that there is an additional data available in the question and you ignore it completely, you're not likely to get it. There is a reason they provide you this data. 99.9% this data is useful. Sometimes they give it just for the sake of it, but 53 degree was a catch. If you don't take this x into account, right, which is the actual distance between the projectile and the point at which the height exists. This is not the point where the height is existing. The height exists here. So the lead which this point, the overall wedge has, is just not 1 meter, but an x also is extra. And then you saw finally, when I wrote y, I used y by x to get the answer and the time and the height and stuff like that. So the wedge has to be 28 by 9 meters. That is the maximum you can go. Otherwise, the projectile will strike it and will not be able to cross the wedge. I hope you like the question. So, yes, calculations mistakes do happen. Do not do calculations mistake because a lot of time goes wasted.